Hello, ladies and gentlemen. This is video number three. Hopefully, we're in the mode of understanding and taking notes. This video says part three. This video is the combination of the last two videos. What you just got done learning was heat transfer, how when things heat up, they behave differently. We're going to really be going after this concept of convection. This is a big time scientific concept. You learned this in seventh grade. You'll learn it again in ninth. It's what causes a lot of things in our planet to behave the way they do. We started out learning about density. Mass is number of particles. Volume is how much space you take up. And without any further ado, let's get into how heating things up causes them to change density. So when things are dense, they sink. If something sinks, that means it falls down. So let's go through. Let's remember what density is. Density is mass divided by volume, how many particles we have in a given space. So right here, I have two particles in this box. In this box, I have six particles. So if we have more particles, it's more massive. We can also adjust, or we can also talk about the volume. I have this concept and we'll return to it. But if I have a bigger box, the density goes down. Well, why does a bigger box mean that it's less dense? Well, go back to your understanding of fractions. This right here is the number on the bottom. That's called the denominator. If the denominator goes up, then the whole number goes down. 1 over 1 equals 1. 1 over 10 equals zero point 0.1. And 1 over 100 means 0.01. So if I make my volume, if I do my volume and make it get really big, that means it's going to have a lot lower density. So increasing the volume decreases the density. Think about it like this. I've got this aircraft carrier. If I've got a really big volume, it's huge, it's a huge boat, I'm going to have lower density. Now, I'm not talking about the weight, I'm talking about the space that it takes up. If 1 over 1 is 100% of the pizza, if I increase the volume, I increase the denominator, I've got half the pizza. If I increase that even further, if I've got a really big denominator, then I've got a small whole number, or I've got a smaller number. Remember, big volume, low density. And you're like, oh, okay, Wadsworth, why are you talking to me this right now? Well, let's go back to heating things up. If I heat something up, it expands. If I heat something up, it's going to expand and get bigger. So if I heat this balloon up, I heat up the air, it gets bigger. That is going to cause it to have a bigger volume. That's actually going to cause it to have a lower density. If you have a lower density, then you're going to float. It says right here, the hot air is less dense. It's less dense because it takes up more space. If it's less dense, it's going to rise. So we're going to go down to this. And this is your step by step process. When I was an eighth grader in math, we'd have to go through and prove, why is this triangle the same as that triangle? Why is this circle the same as that circle? And you might not do that anymore, but we're still going to go through and use this concept proof. So as heat goes up, volume goes up. Remember, if I heat something up, it expands. As the volume goes up, density goes down. So I heat something up, it gets bigger. As the volume goes up, the density is going to go down. As the density goes down, the object is going to float. So we can go through and remember, I heat something up, it gets bigger. That's going to cause the volume to go up. That's going to cause the density to go down, and it will rise. And this goes back, as we said 2 minutes ago, this is convection. Say it with me. We heat it up. The particles are going to expand. That's going to say that they take up more space, so more volume. If there's more volume, the density goes down. And if the density goes down, the object rises. Well, now I'm up here and it's getting cool. If it gets cool, the volume is going to go down. If I'm over here and the volume goes down, that means the density is going to go up. And if the density goes up, you are going to sink. And that's the concept of a convection current. That's what makes my lava lamps work. That's what makes ocean currents work. That's what makes most things work on our planet. That if you heat up, you expand. If you expand, your volume goes up, your density goes down, and you rise. I'd like to go through and I'd like to do the opposites, because if something's true, maybe the opposite is going to work. So let's go through and let's try it out. If we've got low heat, that's going to cause the particles to contract or get small. So we'll say low volume. If it's a low volume, a smaller volume, then that means that we're going to have a much higher density. Think back to the pizza. If we have a small denominator, that means that we've got a lot more of the pizza. So a small bottom number is going to cause the whole number to get bigger. So low volume equals high density, and that's going to cause it to sink. Guys, this has been where we combine density and heat transfer. I hope this makes sense. If it doesn't, please feel free to go back and watch it again. Thank you.